Double angle and half angle formulas. Chapter 7, section 6. So, yep, we're getting more of these formulas in here. And I know that there's a lot of formulas involved. I'll remind you once again that we have a formula sheet that I'm more than happy to have you use. I should point out, as I have in the past, that certain calculus instructors and others may expect you to know these off the top of your head, but I'm being realistic. I've never been good at memorizing formulas, so I do not force my students to do anything that I don't feel that I could do properly. So feel free to use that formula sheet if you can come up with little hints and tricks, and I try to share those at times, things that kind of help me remember it if I have to, then feel free to use them. So more formulas. So double angle formulas. The sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. The cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Another formula for cosine of 2 theta is equal to 1 minus 2 sine squared of theta. Another formula for cosine of 2 theta is 2 cosine squared theta minus 1. And then tangent of 2 theta is equal to 2 times the tangent of theta over 1 minus the tangent squared theta. Now, you may ask, well, why do we care about these? Well, remember our sum and difference formulas, that we did it because we sometimes want to find the value for an angle that does not work as well. So this allows us to find values if we have an angle that's double one that works. So let's say 120 degrees. Now, granted, we could take that down to a reference angle, but I'm just using this as an example. So if I want to find the sine of 120 degrees, well, 120 degrees is 2 times 60 degrees. So all I need to do is find the sine of 60 degrees, which is one of our standard angles. And then I can take the sine of 60 degrees, cosine of 60 degrees, and multiply that by 2. So I can take that right out of our table. And I don't even have to deal with reference angles or anything of that sort. I can just plug it in. So that's the idea, is if we have an angle that's double a known value, and sometimes it's a matter of it's a known value. We know that the sine and cosine, maybe we have the trigonometric ratio for a certain angle. The trigonometric ratio for the sine of 17 degrees, and we happen to have that ratio. Now, if we want to know the sine of 34 degrees, we can use that information to find it. Now, a corollary to double angle formulas is sine squared theta is equal to 1 minus cosine of 2 theta over 2, and cosine squared theta is equal to 1 plus cosine 2 theta over 2, and tangent squared theta is equal to 1 minus cosine 2 theta over 1 plus cosine 2 theta. And you may go, what? Where is this coming from? If you look back at our cosine 2 theta functions, remember we had the cosine 2 theta is equal to 1 minus 2 sine squared theta, and cosine 2 theta is equal to 2 times cosine squared theta minus 1. All that's doing is solving for the sine squared theta or the cosine squared theta. So if you solve those for sine squared theta and cosine squared theta, you will end up with these functions. And then tangent squared theta, that's just sine squared over cosine squared. So put these two on top of each other and cancel out the 2's from the denominators, and you end up with that. So that's why it's considered a corollary. It's just a rewriting or reordering of a function or formula that you've already seen. Yet another corollary to double angle formulas, and this comes off of what we were just looking at, when theta is equal to alpha over 2. So sine squared of alpha over 2 is equal to 1 plus cosine alpha over 2. And remember, our previous formula was sine squared 2 theta was equal to 1 minus cosine 2 theta. Oh, sorry, sine squared theta. Let me go back to that so that it's nice and easy for us to see. We had sine squared theta is equal to 1 minus cosine 2 theta over 2, right? So now we're saying that theta is equal to alpha over 2. So you have 1 minus cosine alpha over 2, and then cosine squared alpha over 2 is equal to 1 plus cosine alpha over 2. And then tangent squared alpha over 2 is equal to 1 minus cosine alpha over 1 plus cosine alpha. So you can see that all we did was, instead of using theta and having 2 theta in the right-hand side of the equation, we're now making theta equal to alpha over 2 and using alpha in the right side of the equation. So we just divided our angle by 2 on both sides. So that's why it's another corollary. It's just a rewriting of the same thing. Half angle formulas. Now, we were just dealing with half angle formulas. That's what these are, but they had squared functions. So now we're taking those down to just the base function, sine of alpha over 2. And you can see we're just taking the square root of the other side. So plus or minus the square root of 1 minus cosine alpha over 2. And remember that plus or minus, anytime you take the square root, you have to, of a squared function, you have to make it plus or minus on the other side. Cosine alpha over 2 is equal to plus or minus the square root of 1 plus cosine alpha over 2. And tangent alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. And then another one for tangent alpha over 2 is 1 minus cosine alpha over sine alpha, which is equal to sine alpha over 1 plus cosine alpha. So you actually see that we have 3 possible formulas that we can use. And depending on the angles we're dealing with, we may choose to use one formula over another, whichever one is going, we feel is going to make it easiest to go through and solve this. So let's go into using double angle and half angle formulas. Use the information given about the angle theta, where theta is between 0 and 2 pi, to find the exact value of cosine of 2 theta. So we have sine of theta is equal to negative square root of 3 over 3, where theta is between 3 pi over 2 and 2 pi. Okay, so we know that theta is in the 4th quadrant. So we want to find the exact value of cosine of 2 theta. So to do that, the reason we need to know which quadrant it's in is because we need to determine what the values are going to be here. Now, it really should be pretty obvious, since sine is y over r, and r cannot be negative, that obviously y has to be the negative value here. So even if we didn't know what quadrant it was in, we would have that information, but we have the quadrant. So y is obviously equal to negative square root of 3, and r is equal to 3. Therefore, x is equal to the square root of 6, again, using the Pythagorean theorem. Now we're looking for cosine of 2 theta. And we can use one of our formulas. So cosine of 2 theta is equal to 2 times cosine squared theta minus 1. So now I can start plugging in that cosine squared theta. So that's 2 times, well, cosine theta is going to be the square root of 6x over r, 3. But we're looking at cosine squared theta, so we have 2 times the square root of 6 over 3, the quantity squared, minus 1. If we square that, we get 2 times 6 over 9, square root of 6, the square of the square root of 6 is 6, and the square of 3 is 9. Just remember, you always square the top and the bottom. Okay, minus 1, multiplying through, we get 2 times 6 is 12 over 9, minus 1, but 1 we can write as 9 over 9. So 12 ninths minus 9 ninths. 12 minus 9 is 3, so 3 ninths or 1/3. So what could have been something really horrible for us to deal with was solved relatively easily using the Pythagorean theorem and a double angle formula. So let's try another one. Using double angle and half angle formulas, use the half angle formulas to find the exact value of the tangent of pi over 12. And we're looking for, so we're trying to find the exact value of tangent of pi over 12. Well, pi over 12 doesn't stand out to me as being a standard angle that we use, and it's not, because pi over 12 would be 15 degrees. And this said specifically to use a half angle formula. So you may look at that and go, well, wait a second, the tangent of 15 degrees, can't I use the tangent of 45 minus 30? And you could, if that's what it allowed us to use. This is telling us to use the half angle formula. So we're looking at tangent theta over 2 is equal to 1 minus cosine theta over sine theta. Now, if we have the angle pi over 12 and we're looking for theta over 2, theta must be pi over 6, 30 degrees. So we're just going to start plugging this in, and we get 1 minus cosine pi over 6 over sine pi over 6. And now we can just pull these right out of the unit circle, is equal to 1 minus the square root of 3 over 2 over 1/2. Combine the ratios in the numerator. 2 minus square root of 3 over 2. To get that, remember, all I did was I said 1 is equal to 2 over 2, and then I just combined them into one ratio. Over 1/2. Cancel out the 2's in the denominators, and then because of that, you can get rid of the 1 in the denominator, because they divide any number by 1, it stays the same, and you get 2 minus the square root of 3. So the hardest part, in my opinion, of dealing with these is just recognizing which formula to use and how to put it together. Once you start doing it, and once you've done a number of these, you will find it's not that bad to work with, but it's that initial recognition of what you need to do, how to get the proper formula for it. So a little bit of practice with this will go a long ways, and I think that you'll find that it's not anywhere near as painful as it looks at first sight once you get a little bit of practice.